Now that we've got an understanding of variables and substitution instances, as well as validity and invalidity from before, we're ready to look at our first logical system. So we're going to look at syllogistic logic, which was invented by Aristotle many, many thousands of years ago, and then refined and cataloged significantly by medieval logicians who really loved reading Aristotle. So syllogistic logic catalogs a number of valid two-premise argument forms called syllogisms. Each syllogism is constructed from the following four statement forms. So the first is called A, very simple name, and the form is all S are P, so that would be something like all dogs are mammals. The logical terms in there are all, and then R works as a connector. So all is our logical term. And our content is what we replace in for those variables. Dogs, mammals. That's the particular content of that concrete statement that's an instance of that form. The form I is some S are P, as in some mammals are herbivores. E is no S are P, as in no dogs are herbivores. And finally, O is some S are not P, as in some mammals are not carnivores. This is a statement where we actually have two logical words, some and not. Both of those have to occur to be an instance of this O form. So what we see in this chart is that we can construct statements of English from these four forms by substituting English terms for the variables S, which is informally for subject, and P, informally for predicate. And we can also do the reverse. So if we see sentences like the ones to the right in English, we can analyze them to determine which of the statement forms they take. Now, the full syllogistic logic developed by Aristotle and the medieval philosophers who studied him cataloged a large number of valid syllogisms. Again, all constructed from arrangements of the four statement forms we just looked at. We're going to focus on just 4 valid syllogisms. They each have names. The names of the syllogisms are not that important, but they're a kind of useful mnemonic for the 3 statement forms in order that make up the argument. So the first one is called Barbara. Each of these statements is of the form A. So it's all X are Y. That's of the form A that we just looked at. All S are P. All X are Y. All Y are Z. From those 2 premises, we can conclude that all X are Z. So we get the order of the statements A. That's the vowels in Barbara. That's how it gets its name. So what do we know? This is a valid argument form. Since this is a valid argument, any substitution will also be a valid argument. So in this example, cats is substituted for X, vertebrates for Y, and have kidneys for Z. So we get all cats are vertebrates, all vertebrates have kidneys, all cats have kidneys. In syllogistic logic, the order of the variables in the sentences is very important to getting valid argument forms. So keep that in mind. The next valid argument form we're going to look at is called celerant. So this one goes no Y are Z, all X are Y, so no X are Z. Again, pay attention to which statements have which variables, and make sure if you're trying to come up with an instance of this form that you obey the rules of a uniform substitution instance. So below we see an example where y is apes, z is have tails, and x is humans. No apes have tails. All humans are apes, so no humans have tails. Our third valid syllogism is called Darii. This one goes, all x are y, some z are x, so some z are y. For example, all dogs are mammals, some pets are dogs, so some pets are mammals. And our final valid argument form is called Ferio. This one goes, no x are y, some z are x, so some z are not y. Here we have that sneaky not that's important to remember. So in this one, x is substituted with trees, y is substituted with can run, and z is substituted with conifers. And here's a silly instance. No trees can run. Some conifers are trees. Some trees cannot run. A ridiculous and not very useful, but nevertheless valid argument. We've looked at 4 valid syllogisms so far, but it is important to note that not every combination of those 4 original sentence types we looked at can be used to construct a valid argument. So you can come up with pairs of those sentences as premises and one as a conclusion that give invalid arguments. So here's an example of an invalid argument form. All x are y, some y are z, some x are z. This one looks a little bit like Darii, but the order of the variables is different, making it invalid. Here's an example where the substitution instance is chosen such that it illustrates that this argument is invalid. We've got 2 true premises and a false conclusion. So onions is substituted for x, plants for y, and trees for z. All onions are plants. Some plants are trees. Both true. False. Some onions are trees. Since we have 2 true premises and a false conclusion, we're showing that this argument is invalid. But sometimes it's not that obvious that one of these argument forms is invalid. So there we had a false conclusion in this first example, the one we just looked at. But in the latter argument, the premises and conclusion are all plausibly true. So this one goes, all insurance agents are people. True. Some people like dogs. True. Some insurance agents like dogs. Seems pretty likely to be true. The problem is that that conclusion doesn't follow from those premises. So that argument might seem plausible unless you evaluate the form. And that's why looking at the form of an argument can be so helpful. Sometimes it isn't immediately obvious that an argument is bad. In the last video of this lesson, we'll look at a technique for proving that an argument is invalid. And then we'll end by covering a few more logical concepts beyond soundness and validity.